The next chapter that we deal with in chemistry is solid state. This is a pretty simple chapter. It is just that you'll have to be able to visualize properly in 3 dimensions and apply simple geometry to solve the questions. So this is the first question that we have. A substance AXBY crystallizes as face-centered cubic lattice. Atoms A occupy each of the corners of the cube, and atoms B occupy the face centers. We need to find out the values of x and y. So for solving this question, you must first know the geometry of face-centered cubic. It is a cube with atoms at its corners and face centers. Now, these are the edges which are behind. Yeah. Now, atoms A occupy each corner of the cube. So let me mark them by black dots. Eight atoms of A are located at these positions, and one over here also. Now atoms B occupy the face centers. We already know that face centered cubic has atoms over here. So this is the face center and this position is occupied by B. This is for the top face, this is for the back face, for the front face, for the bottom face, for the side face and another side face. So these are the 6 locations of atom B. Now we need to find out the overall formula in the form of AXBY. So this can be easily found out. This is one unit cell of FCC, that is face centered cubic. So the composition in one unit cell will be represented in the whole system, and that will be represented in the formula as well. So let us see how many atoms of A are there in one unit cell. In one unit cell there are 8 atoms on 8 corners for A, but the contribution of this atom is not 1 in this unit cell, because this atom is shared by 8 other cubes, 8 other similar unit cells. You can see how this atom will be shared by the unit cell which is just here, the unit cell which is here, the unit cell which is here. So 4 in this plane, and there will be 4 unit cells in the upper plane which will share this single atom. Therefore the share of this single atom in this unit cell is 1/8. Similarly, for all the atoms in the corners, their share to this unit cell is 1/8. Therefore the total share of A atoms is 1/8 into 8 such atoms, that is equal to 1. Therefore overall there is only one single A atom in this one single unit cell of FCC. Now for the atoms B, they are located at the face centers. So this atom is shared by 2 unit cells, one unit cell which is below and another unit cell which is on top of this unit cell, just on top of this unit cell. So these 2 unit cells in common share this atom. So therefore the contribution of this atom towards this unit cell is half. Therefore similar logic applies for all the 6 of them. Therefore the contribution of atoms B comes out to be equal to half into 6, that is equal to 3. So in every unit cell, for every single A atom there are 3 B atoms. Therefore the composition of the compound becomes equal to A, B, 3, and this is our final answer.